This video demonstrates how to accelerate multiply accumulate operations using the CCRX compiler. Multiply accumulate operations are frequently used in AI and signal processing programs. The RX microcontroller supports multiply accumulate instructions to enable fast operations. Multiply accumulate instructions can effectively improve the execution speed of multiply accumulate programs, as both multiplication and accumulation are performed in a single instruction. By default, the CCRX compiler does not generate multiply accumulate instructions, even when optimization to improve execution speed is enabled. Therefore, we will explain how to accelerate your programs by enabling the generation of multiply accumulate instructions using eSquare Studio. First, in the eSquare Studio project, navigate to C++ Project Settings, C++ Build, Settings, Compiler, Optimization. Then change the optimization level to 2 or max and the optimization type to Optimizes with emphasis on execution performance. Next, navigate to Common, CPU. Then check Saves and restores the accumulator and interrupt functions, Save ACC. This enables code generation using accumulator registers, resulting in the automatic generation of multiply accumulate instructions. We measured the effect of the Save ACC option on such a program. As a result, the multiply accumulate instructions improved the program's execution speed. Please note that the multiply accumulate instructions currently generated by the CCRX compiler are only for signed 16-bit multiplication with a 32-bit output. Therefore, multiply accumulate instructions only apply to multiplications that involve 16-bit operands and 32-bit results. The multiply accumulate instructions are signed. They are not generated for unsigned types. Please also note that the compiler will not generate multiply accumulate instructions if it determines there is no benefit in using these instructions. When a loop with multiple expansions is performed, it becomes easier to benefit from multiply accumulate instructions. Therefore, you will get better results by setting the expansion maximum number, under optimization, to 4 or higher. One drawback of the Save ACC option is that it may worsen interrupt response time. That is because the compiler conservatively generates code to save the accumulator registers. If there are no function calls in an interrupt function, the compiler can accurately determine whether to save the accumulator registers. If there are function calls, it must take a conservative approach. As a workaround, you can add no ACC to the pragma interrupt directive to instruct the compiler not to save the accumulator registers. If the accumulator registers are not used anywhere in the interrupt function or its calls, add no ACC to improve interrupt response time. Accumulator registers are not used for simple bit manipulation, logic operations, comparisons, or assignments. In such cases, however, we recommend checking the output assembly code to confirm that no accumulator registers are used before adding no ACC to the pragma interrupt directive. Also, if you are using the register bank save function by specifying bank = n, there is no need to worry about the Save ACC worsening response time. The register bank save function is available only for devices with register banks.